Welcome back to Daily Stand-Up. Today I'm going to report progress on my API Gateway microservice. Basically, so I'm making a microservice specifically for my API Gateway. I'm using Oscillate API Gateway, which is just an open source API Gateway for .NET. It's pretty clean. It seems relatively straightforward. Some features you immediately kind of get out of the box with it is rate limiting. You define upstream and downstream routes just by specifying the host and the port name. Some things that I have to research in terms of what it, I don't know if it does it or not. I have to look at if it handles any kind of logging, and I have to see if it handles what it does with authorization, and also redirection. So there's a couple things I still have to look up, but the main functionality is I want to take my engine's front end, which is the React front end with its respective back end for front end endpoints. I want to take that, and now I need a route instead of going directly to my microservice, so my one engine API microservice, I need to route through my API gateway. Again, this is a lot of this is a design decision, but you get the advantages of throttling. I can set a rate limit of 10. I can't send more than 10 requests a second, otherwise it'll give me an error. And I'm gonna have that actually on a video coming up pretty shortly. So I got the code done last night, kind of late, but I got a working example. So I built a new just .NET Web API. That's going to be my new microservice to only do API Gateway stuff. So again, I'm trying to create this very loosely coupled system. So an API Gateway is crucial to that, and I'm not going to use any cloud native provider stuff. Like I know, AWS has their API gateway, Azure has their API gateway, but again, I don't want to pay for it, right? So the costs add up very, very quickly if you've ever used cloud stuff. And I know there's a free tier, but the free tier stops pretty quick, right? And I want to avoid that, right? And there's really good open source options. So I'm going to go with that. Obviously, I know you have to host it afterwards, but when I'm running it locally, it's nice to have that control and see exactly what it's doing and basically handle what's happening. I know it's going to be, it's free, it's open source, so it works really well. And also it's a big one. It's probably the biggest. So for open source API gateways for .NET, so can't beat it. So I have some code that basically is a proof of concept. So I'm calling from my front end now to my API gateway, and it routes me to my engine's API. So it works pretty well, and I set up just kind of a rudimentary rate limiting of can't send more than 3 requests every 10 seconds, and that works. So I'm very happy about that. So I got that functionality in place for when I actually configure it. So it's super nice. But again, it lives in its own repository. It's separate from everything else. So my remaining work, which is in my to-do column here, is basically adding that microservice to my Docker Compose file that gets called on my front-end's application startup. So this ticket specifically is, did it not save? Huh. To be honest with you, I don't think it's saved. Or maybe I didn't save it. So I did have some description here. What? Oh, it didn't say. Okay, well, I had some points here. Basically, create new .NET Web API, install Oscillate, and create functional prototype. Okay. Basically, routes are set up and working. Rate limiting is in place. Okay. All right, so that's what I'm doing now, and that's what you'll see code on. Maybe today, maybe tomorrow. I'm not sure. I'm going to have a pull request video or a code review video later today for that code, so we can kind of walk through it and see how it all happens and see how it all works. So this ticket is going to be moved into done at the end of today. So I'll report on the progress tomorrow, and that's kind of where we're at. So the next one following up with that is going to be, I'm going to be dragging in API Gateway, add to Docker Compose, and that's really where this is going to, be lumped into everything, right? Once I add it to my Docker Compose, I'm saying, hey, stand this up. But there's some things I might need to do before this, to be honest with you. And this is the complications you're seeing of making a system, right? There's so many decisions. There's countless number of decisions, and every time you implement something new, it creates 10 more decisions and 10 more problems. And it's like, you figuring out everything that has to happen, because you don't want to just create this system where I have one monolithic application that does everything and that you have to scale everything all the time to make anything happen. That's not sustainable, and that's not how large enterprise applications are made, in really modern times. They used to be made like that, and there's a lot of refactoring efforts to move towards some semblance of a microservice architecture. But that's kind of where we're at, right? So for me, my needs are, I have this engine, I have an engine simulator. Okay. I'm anticipating sending, 1,000 data points every minute of what's happening, from that down to my back end. That's a lot of data points just for my system, and I need to basically couple that some of the back end services together, right? I want to create this messaging platform that says basically, okay, we've seen this engine data for the past 5 to 10 minutes or something. We have to run analysis on it to see, okay, how is this trending? How is this new configuration of the engine? How is that handling, or what is that basically doing to performance? Is really what the information I'm trying to garner from this. And then I need to notify other services. Okay, if we have high heat from our engine, we have to notify something to happen. We have to notify our notification service to register as something is happening, like as a high heat error, and then signal that back to the front end. And then we need to do we also have a social component of, we say, we've seen, we also see user engines that have a similar configuration or running into similar engines. Let's notify you of that to see if you want to look at their specs and see if you can get anything from there and bring into yours. Now, the reason you can't do this in a just a linear synchronous pattern is because you could see how long that would take, right? I would be basically saying that, okay, every request I send to my back end, I'd perform my analysis on it, then I check it for heat, then I check it for social, and then you've created this linear path, and then so it increases basically exponentially as you increase requests, and that's not what you want. So, and the second you add more users, your front end's just going to entirely collapse. So that's what we're fixing. That's what the message broker fixes, right? So now we've created this path where we're just publishing requests to this queue, and we have these registered consumers of that object that are now going to do something with it, and then send a notification back to our front end that is registered to consume whatever that is. So it's very, very powerful, but it's very complicated, and it's hard to it's hard to get it right, but once you have it in place, it's super, super powerful. And I get really excited about it because it's such a big, it's a lot to implement, but it's going to be such a powerful system once it's in place, because everything should go smoothly, right? Your front end should not care, what in the world is happening in the back end. All it should be is saying, hey, send this somewhere. We don't care what it is, but we're going to continue doing our thing. We're going to send messages to this, and we're going to keep going. Whether the service is offline, doesn't matter. Whether we're getting errors, doesn't matter. It should just be sent them. So that's our goal, and it shouldn't matter what any of the backend services are written in. They could be written in Go, Rust, JavaScript, Python. It doesn't matter. And that's really the power you get from message brokers, because nothing is coupled. Everything is just registered to consume these messages, and it works really well. But we have a lot of work to get there. We have the framework. We're assembling the framework, which I'm really excited about. We have a lot of pieces. We have now a lot of moving pieces in place. That is, it's coming together. So I'm excited about that, because we have our front end. Obviously, engine simulation is going to be a massive amount of work, and that's going to be. I recognize that. So that's is a large chunk of work, but I'm trying to get all the system design stuff kind of in place before I get too far with the engine simulation. But we have the front end. We have the API gateway. We have RabbitMQ set up, and we have a consuming service. We have a lot of the framework set up as a rough prototype, and that's kind of where we're at, and the prototype is working. So I'm very happy about where we're at with the prototype. And to make a video showing you every part of the system so far is going to be a long video. And this is what I'm trying to do incrementally, is to show you each step, because everything. There's such massive topics happening here. And really, you could delegate all this work to teams for each service, and that's really where I'm trying to get this project to be, is a model for myself of how to architect these things. And I can't say how long this is going to take me, but that's why I'm trying to get the framework in place, so I can begin to see advantages of the way to do the system design. And I'm real excited about it. So anyway, that's all I got today. So I'll be reporting on progress tomorrow, and I got a whole bunch of videos coming up. So, all right, take it easy.